Um, thanks to the people at BSides Perth for inviting me to this, which is my first BSides talk ever. The main title is Running Up Chat Hill, A Beginner's Guide to ChatGPT. The alternative title is that AI won't steal your job, but Stefan Prandtl just stole mine. Actually, our talks, despite I've never met Stefan, Stefan's never met me, but I think there's an awful lot in common. Stefan's looked at it from very much a conceptual viewpoint of AI, whereas mine and why it's awful, and mine is more about the practice of AI and why it in many cases is awful. Okay, so the general structure of the talk is going to be, firstly, I'll start and talk about how do AI systems, specifically LLMs, work in a little more detail. Then look at where the LLMs that are available now can be useful in a cybersecurity context and when and why they aren't. And then talk a bit more about where the field's been, where the field's gone, and my guesses as to the future of AI in cybersecurity. I'm particularly saying my guesses because it really isn't said enough. Like any future scientific endeavor, anyone that's telling you where AI is going to go is at some base level guessing, and that's a point that seems to get lost sometimes. So who am I? After my engineering degree in computer engineering, I went and did a PhD in artificial intelligence, specializing in biologically inspired AI and robotics. Old Man Yells at Cloud was the other alternative title for this talk. Then I did 15 years of research combining cybersecurity and AI for Defence Science and Technology Group in Adelaide. About a year and a half ago, I ended up leaving there and becoming a security architect for Leidos. All the opinions expressed in this talk are solely my own and do not reflect the views of my current or past employers. So I'll start off by discussing AI and large language models. So AI problems, much more comprehensive definition earlier from Stefan, a little more of sort of the working definition that it's kind of gone by in terms of research is really just problems that can't be solved by the analytic approaches that you normally take when you're programming answers to problems. This is a very nebulous moving target of a definition. Some of the general themes where this has been used, problems that are too complicated to be reduced to a programmatic response, so particularly anything interacting with the real world, where you're getting computer vision and processing visual inputs, where you're interacting with the world in terms of robotics and such, are cases where you run into problems very quickly that aren't reduced to existing algorithms, and so you have to take other approaches. Anywhere where you're dealing with a human partner or conversely a human opponent is an area where a direct sort of programmatic response isn't necessarily going to address what the other person will do. In games, once you get to any sort of game with any sort of complexity, even quite formally defined games, that computational explosion leads to a problem that you can't just solve analytically, or cases where the solution isn't really fully defined, an element of you know it when you see it. Now, so AI solutions. A lot of the solutions to this problem boil down to a very particular workflow, and LLMs are a particular example of this, which is classification or supervised learning. What this really boils down to is you get a massive set of data and you get some people to label it and tell you, for example, the classic one, does this picture have a traffic light in it? You get a bunch of humans to go through and tell you whether there's a traffic light in it, possibly as a way of getting into logging into a particular service. You then use some form of general statistical model where you can feed in the data and get a prediction out, and you can use something to feed it lots of data and gradually iterate through until you have a prediction that is sufficiently accurate. As a point that Stefan made before, is that the size and content of this data set is extremely important. I'll be harping on that a little more later on, but the general idea is that the algorithm is going to optimize around what it finds is the easiest solution, which may not actually be what you were trying to solve. The classic example is a tank detector that was meant to distinguish Russian tanks from American. What it turned out it was doing was telling whether there was snow there, because all the Russian tanks were pictures in snow and all the American tanks were pictures in grass. So large language models follow this model. The data is pretty much every piece of the written word they could get their hands on, whether they were worried about the license agreement around it or not, as is now coming out in court. The label, in their case, rather than have a human label, because that means you have to hire people, what they did was, doing the next word prediction, was to block out words in the text and test it on its ability to guess what the next word was. The learning goal is to, for starters, just given any piece of text, predict what an appropriate next word is. And the long-term goal of that is you do it enough times and you train it enough, you can get systems that are generating entire documents based on a series of input that's provided and the model that's already been trained. So there are a couple of sort of structures that are involved in this in the transformer diagram that Stefan put up earlier. One of these is feedforward neural networks. What these are is basically a line of summing nodes, the hidden layer, that have random weights as to the input to them. The input is a set of real-valued vectors. So whatever input you have to digitize, so a picture gets digitized into sort of individual pixel values. You then have a hidden layer that weights the sums of the inputs. They then pass the inputs through to an output layer, which is again a weighted sum. The technique it uses to learn is called backpropagation. What that is you feed in one input, the neural net pushes out its guess as to what the answer is. You then check the answer you already had, and depending on whether you're right or wrong, you adjust the inputs. If it was right, you reinforce the inputs that gave you that right answer. If it's wrong, you de-emphasize the ones that gave you the wrong answer. Over time, you gradually adjust the weights, so hopefully you're getting a reasonable probability that the input layer is producing the right output layer. The other part that works in an LLM is what's called the self-attention mechanism. As I said, what you need to do in this is put in a set of vectors, and what LLMs do is they use either words or what they call tokens, which is either a word or a part of a word, like half of a compound word. They represent each of these as a location in a really big high-dimensional space. So they're all like points in n-dimensional space. And they've designed this space so that words that are close to each other have similarity in some aspect. It's a very big dimensional space, so it's not necessarily just spelling, it can be other concepts that are captured in that. And then the self-attention mechanism performs similarity computations to connect those inputs together. So to sort of take a couple of examples from Arnold Schwarzenegger movies, the self-attention mechanism, if you gave it, if it bleeds, we can kill blank, would pull from information that's already in the context. So if it bleeds, we can kill, well, it already mentions it, so that might be it in that case. You can just bring it forward from previous. Whereas the neural nets, through the training, are connecting words to the wider set of sentences that have been trained on, not that specific context. So if we go to the Arnold Schwarzenegger movie Batman and Robin, he says, what killed the dinosaurs? And then the neural net could pull in, okay, well, the Ice Age is an appropriate response in that case. And it does this in sequence over a massive number of layers. I think 96 is the guess for at least one of the main, like ChatGPT, producing billions of weights that are dealing with, I think, about a sort of corpus of words far bigger than anyone's going to read in their lives, and gradually, through training, can produce something that will predict the next word that fits. That being said, as Stefan pointed out, the people that made it don't know exactly what's going where. A lot of the information about how it works is actually other researchers going in and doing research into how you can pull that information out. This can cause issues. One issue that can happen here is that the people who created it basically say, oh, well, this information, there is no way X could happen with this. Like, there's no way that it doesn't store whole images in DALL-E or Stable Diffusion, and then some other researchers go and ask the right question and just pull out a picture from National Geographic that happened to have been used enough times that it's in there. So LLMs generate chains of text that match the context in the data set. That text is coherent, it fits the rules of language, the grammar is good, it sounds like a general, I guess, high school level kind of speaker generally. And because this neural net has so many learned node weights in, it ends up being able to store information about grammar and also facts that it can pull out to help put in an answer that makes sense. So now we'll go into a bit more sort of how LLMs relate to cybersecurity. So I kind of assume, just in case someone hasn't actually used it, chat.openai.com is how you can get access to ChatGPT 3. Also, Bing, if you go to Bing, it gives you lots of very clear instructions on how to access Bing Chat. And you can start asking it questions. So here is its argument for why Hot Fuzz should have won the Oscar for Best Picture, which it should have. So I've just asked that. It's come out with a detailed bullet pointed, if kind of generic, argument as to why Hot Fuzz should have won Best Picture Oscar. You can, because it works on the context it's generated, that includes its own work, so you can ask it to refine solutions, do them in different formats. You can tell it that it's got it wrong, and it says sorry, and it kind of tries to do it again, but that's a bit... because of the nature of it, completing sentences, it doesn't really absorb it. And you can input a whole heap of text beforehand to guide the response. Most of these programs are doing that anyway. The controls on, say, not saying offensive things or that are built in to form the input are basically full sentences that have been included before you ever put anything in, which is interesting from a cybersecurity perspective as well. So as just some quick examples, here's kind of the good, the bad and the ugly of trying to get information out of these systems. So I've asked, what is the Australian Information Security Manual's advice on selecting passwords? So one version of Bing has given me an answer which is correct, but only a small part and kind of devoid of context. It's actually cited the government website. It said that passphrases are recommended. It's suggested the 14-character long passphrase, which is kind of one of the recommendations, but it's not all of them. It doesn't mention, say, if you go and read the ISM, that talks about single factor versus multi-factor. It talks about the different level of security of the network that you're setting the password for. And also, it's not giving you hard rules. It's a set of suggested controls for a system that you do a risk assessment process. That's all useful information, but they're not going to give you it. Then if you ask ChatGPT can't search the internet, whereas Bing can. So it gives you a very general response. It says that really you need to read it yourself to find out, as if that wasn't what I asked it for, and that security can evolve over time, but it doesn't give you a hard number. Then you get this other one that asks, where I've drilled down and asked, is there a specific minimum password requirement? And it said, oh, it's 13 alphabetic characters according to ASD, and it cited a website that isn't a government website that's giving you the 2016 recommendation, stripped of all context and just told. So in this case, it is very confidently giving you a wrong answer. And it cited its wrong answer. Do not ask ChatGPT to cite things because it makes up the cites. And if you haven't read about it already, there's a lawyer in the US who used it to generate entire case histories for a case, and it is currently going very badly for him. The nature of LLMs is you can also ask them to generate code for you. So here's a quick example. I just did 3 circles in Paint. Can you write some code for me to tell me where the centers are? I then asked it to redo it immediately, so it just gave me the coordinate rather than giving me a new picture. So it happily gives you a set of code that gives you the 3 centers of those. Looks good, then you run it, and it gives you, I didn't count, but probably about 15 centers of circles, and it got 2 out of the 3. So, yeah. I told it, it found too many circles, so it gave me a big description of why this could have been a tricky problem, thresholding, stuff like that. which didn't really apply to this issue because I just painted circles. And it gave me a whole nother approach via code. This one gave me one of the circles right, but then broke, and I had to quit the terminal. So I guess this is an example of what it does in terms of code. If you ask for, say, Nmap scripts and stuff, because the corpus has a bunch of information on how to run Nmap and stuff, it'll give you pretty good guesses as to how to run those scripts. So, as you've seen, it very cheerfully gives you answers. They aren't necessarily accurate. And Stefan hit a little on this. But yeah, the thing is that, as we've said, what you train on and how you design an AI system is particularly important. Neural net systems are sometimes described as brittle, in that if it's matching the data and it's matching the problem, it'll do great. As soon as it deviates outside of the proposed problem or the design or what the dataset covers, it falls off extremely quickly. I don't personally, people use the term hallucination, but I personally don't like that because for me, I guess here's the example. I went out and played pool with some people last night, and say I'm playing pool and I hit the cue ball and it pops off the table and into someone's beer. Saying an error from ChatGPT is like a hallucination is like saying me doing that and then saying, oh, my elbow slipped and that's why the cue ball went off the table, when everyone knows it's just I'm a bad pool player and there's a fair chance that when I hit that ball, it's going to end up in someone's beer. It's inventing an extra explanation for something which is actually intrinsic to the model. The model has kind of a hit rate, it's going to hit things, it's going to get right a bunch of the time, but it's also going to get it wrong a bunch of the time. In terms of coding, as soon as you get into any coding that involves mathematics or any tracking of complex state, the accuracy is going to start to break down pretty quickly. There's already a couple of good studies and technical reports out. Someone evaluated it for use in detecting vulnerabilities in code, which you can do. You can show it a bunch of code and say where it thinks that there are potential vulnerabilities in. But they found that I think a dummy classifier where you're doing like binary classification is just as good as using ChatGPT. Another example, people compared the effectiveness of asking ChatGPT something versus Stack Overflow. They actually found Stack Overflow was more accurate in their study, but the people using ChatGPT trusted it more because it sounds more confident. Now, all these issues regarding accuracy also kind of apply to AI art systems like DALL-E and Stable Diffusion, because they are fundamentally doing the same thing, except rather than predicting the next word, they're predicting the adjacent pixel. And they're trained on a massive body of work of art, similar to ChatGPT being trained on a massive body of text. And so you get some of the same similar issues. So the issues you have that ChatGPT can't really do maths that well, or that it starts to get errors as you go on, or complex code, appear in terms of the perspective and shadows in a work. So this is off DALL-E's webpage. This is one of their examples of what their system can produce. And just you can quickly notice that there are shadows on the front of the horse, but no shadows on the back of the horse. And if you look particularly, if you want to guess whether a piece of art is AI generated, looking at the shadows in buildings and whether they actually match the shape of the building is one good way to do it, because these systems aren't that great at the math that's required. The issues with fact recall and analyzing the world come up in terms of the anatomy. As you see, this astronaut has these weird mittens, the bridle doesn't work right. The horse appears to have some sort of badge or label on its side, which is strange. Yeah, the anatomy thing that I think lots of people would have seen, that you can, if you want to know if a picture of a person is generated by AI, you check if the fingers are the right number and are in the proper configuration, kind of like you're in a fantasy story and like you're dealing with some sort of like illusion. And also things like three-dimensional objects don't match the space that they're in. Houses don't have the kind of doors and windows we'd expect with a house. All the things that humans learn via greater experience with these objects, rather than just learning from art or words. So, That's a bit of a coverage of some of the use cases of LLMs as they are now. So the last bit of the talk, I'll talk about the general field and the future of cybersecurity AI. So one thing with AI problems in general, and it's one thing that ties into a lot of the predictions that you would encounter in the wider media or on LinkedIn or on the discussions of these kind of things, is that, as I mentioned before, AI techniques are really dependent on the data, both the size and the quality of it in terms of its pertinence to the problem. And once you get outside of the bounds of that, the performance falls off really quickly. Tailoring general techniques, so all of these things like neural nets and stuff like that are general techniques that are then tailored by data to a particular problem. And that's difficult. It's as difficult for AI as for any other situation where someone has a proposed general solution to a problem but has never actually gone into field and tried it on the actual problem they're solving, which I think in many industries, if you're dealing with, oh, well, this solution we used in another industry and I'm applying it to yours, there's some work fitting it to that industry a lot of the time. And a lot of the predictions around AI seem to assume this is trivial in spite of the wealth of evidence, both in AI and outside, that this is a really hard problem that sometimes doesn't work. The reason I've got that picture up is a particular example of machine learning, which is quite recent and hilarious, which is that there was a group working with the Marines in the US to do a visual recognition system. To detect humans walking towards it. They spent a whole bunch of time, they got a group of Marines in to train watching them walk and generating detectors that could then pick in any piece of film whether there was someone moving around. And I mean, then they went and let the Marines on the final day of testing try and defeat the system. And they did a range of techniques. One of them did somersaults rather than walked, and the camera didn't pick that up. I think someone actually got a bunch of leaves and like walked slowly holding them like a tree. And a couple of guys, a couple of Marines who I will buy a beer if I ever get to meet them, got a cardboard box and hid under it like in Metal Gear Solid and walked towards the thing, and the camera didn't notice them. So that's a great example of how it's designed for this very narrow problem, which can break down as soon as you're trying to apply it to a broader issue. Another example, one of the sort of big, about 10, 15 years ago, IBM had a system called Watson, which won Jeopardy! Against a couple of the best human players, Brad Rutter and Ken Jennings, took them on in TV Jeopardy, was able to analyze the questions, come out with answers. Watson was then sold to a lot of companies as a general solution for AI, like for using AI to manage knowledge. And they did particularly a really big focus on the medical field. And if you Google for stories about this, it did really, really badly, because it turned out that the data inputs for medical problems were quite different to whatever it had for Jeopardy, and that the answers required were quite different to just answering a quiz. So they were doing very badly. I think by about 2021, they'd started to get at least a little bit of headway there, but then ChatGPT and stuff came along, so I'm not sure how that would have gone. Going to cyber AI, and here I will slightly diverge from the previous speaker in that I think there are like some bits of hope. I agree that Stefan talking about ChatGPT enabled waifus is terrifying in all sorts of ways. But one thing about the cybersecurity problem domain is that it's actually, by the standards of all the domains you can apply AI to, extraordinarily hard. The way most AI techniques work, including LLMs, is they apply a general model to a massive set of data. And particularly for LLMs, they're looking for the most common thing, the most something that is broadly acceptable and trusted. This has some other issues with knowledge recognition that I didn't touch on before. If you have one authoritative source and 10 general people discussing something, and you ask ChatGPT for the result, it's going to tend to veer towards the general answer rather than the specific correct one. But the issue as well for cybersecurity is that finding the general answer, particularly in areas like exploit development and stuff, what you're doing is not trying to find the general common answer, you're trying to find where the general answer breaks down. You're trying to find edge cases. And that isn't something that these kind of AI systems are designed to do. They're designed to go where the data is, not where the data isn't. I think when you look at exploits like Rowhammer that are reading RAM based on physical co-location of things in the chip, that's not something that you're going to pull out of computer data. You've got to find the data that tells you that before you can then have any AI that's going to be able to even approach that in some way. Also, because data is so essential in cybersecurity, both attackers and defenders are dealing with restricting data anyway. Attackers lie all the time because that's what works. Defense, in response, limits access to data when defense occasionally doesn't lie themselves in sort of deception-based techniques. So a data-driven approach has the trouble that it's in a domain where everyone is trying to manipulate and restrict information. And really the sort of the ultimate point here is that any cyber AI system is going to be targeted and manipulated because that's part of cybersecurity. There's already, I think, a good 10 years of research into adversarial machine learning, or AML, which is the approaches of how you can undermine and deceive machine learning. The classic example for most of that period, it's really focused on visual systems and audio. So here we have a picture of a duck, or picture identified as a duck by a visual recognition system, put in some noise, looks like a horse, ditto for audio, and there's already a whole heap of work on how to deceive LLMs. LLMattacks.org is a website discussing research into automatically generating counters to LLMs. Also, if you want to try it yourself, Gandalf.lakera.ai, thanks Michael for pointing that one out to me, is one where you can try it yourself. There is a small LLM that is meant to not tell you a password, and you can use more and more elaborate prompts to get that password. There was a particular attack called Do Anything Now, which was a big block of text where you could basically bully an LLM into telling you whatever it wanted rather than what it was required to do. And this isn't the nature of most domains that AI goes into. People designing AI cars aren't designing it around the rest of the road, rest of the drivers actively trying to drive them off the road, because that wouldn't happen and there are other controls around that. Whereas cybersecurity is an area where trying to undermine other people is what a fair number of people get paid to do. Another big issue with the idea that that AI can take over a lot of the jobs people say it does, has a really great example in autonomous truck driving. Autonomous trucks were meant to be replacing human-driven trucks already. If you look at, say, a lot of these papers that get produced where they analyze how many jobs are going to be taken over by AI, they have a habit of saying these whole blocks of industry will be taken. And one of the ones that was a really big target was truck driving. When Waymo really started gearing up its work on autonomous car driving, sort of truck driving was built in there as, oh, this will actually probably be easier, and there's a lot of money in it. But Waymo, who are really the preeminent sort of company in this area, has just announced about a month ago that they are basically putting on hold any autonomous truck driving research. It's just the same problem scaled up, fundamentally. They still have a battery of sensors that can do it. There's potential scope for very large profit. They haven't gone out and told people why. As someone who's worked in this area, I have some hunches. And I think it ties into basically how truck drivers are like CISOs. One of the fundamental hardest bits in autonomous driving is high-speed merging, so merging on highways. So firstly, it requires a lot of assumptions about what other people are doing. But I think fundamentally one thing that is underplayed as a problem is that as soon as you're driving alongside other cars at 100 kilometers an hour, there's a bunch of risk you are now accepting. There are so many moving pieces, and other people can move faster or brake or whatever, that there is no guaranteed solution that eliminates possible risk. Thanks. When you build that up to a large a B double traveling at that speed, then that risk is going to be even far higher, with a massive potential impact on anyone else at the road if you get it wrong. I think potentially, when you're dealing with AI problems like this, you run into the issue that there is no real way of eliminating that risk with an algorithm. There is always going to be a risk that that goes badly. And that's both a problem in terms of the micro level of designing a system that's going to work in it, and it's a problem at a macro level for a company. People have talked about the best thing about one of the advantages of robotic drivers is that you won't have accidents anymore. The flip side of that is if you design one of those systems and it does crash, then at some that robot was doing what it was designed to do, and you're accountable for it. So one issue that these companies haven't really been able to grasp yet, that humans do because we have it as part of our jobs, is to accept that level of risk and the consequences for it. And truck drivers, as well as accountants, lawyers, electricians, up to C-suite, have as a key part of their job, not only am I supplying advice or doing a task, but I'm also standing by my work. If it goes badly, I'm the liable person. And I think that's a big issue that robotics hasn't actually grasped. I guess it could grasp it if the company assumed all the risk, but they really don't want to do that, I imagine. I guess what they have done in terms of that is basically put the risk back on the human driving, or just avoid it. So I just do some final conclusions and let everyone, let us get to the wrap up. So just some quick takeaways for today. ChatGPT is good at what it is designed to do, which is analyze writing and produce new writing on a variety of topics, well written. ChatGPT gives you the common answer, whether that's good or bad depends on your question. It has built in that it is going to get things wrong a fair bit of the time because it is not built to be correct. It's built to write good English, which are different things. And so if you are going to use it in any way, that has to be introduced at the start or the end, whether it be by better sort of pre-design or by having someone accountable at the other end. And don't, I'm at left, I guess, and don't put proprietary company data in it in case you were thinking. Just very quickly, takeaways for the future. Cybersecurity is a particularly nasty domain for AI, which is, I guess, some hope if you want to push back on it. Assumption of risk is a really hard problem that AI companies will find very difficult to handle. Just to briefly get on my soapbox, claiming your invention will replace an entire field of endeavor, like they did for radiology back in 2016, is super mean even if it were true. And when you're just kind of guessing and it turns out you're wrong, that is pretty horribly mean. Tailoring AI to domains is much harder than people let on. And one other little sign of hope is all the well-established cybersecurity practices like segmentation, patching, multi-factor, things like that. AI is not a wizard. It cannot magically work out a way around really well-tested and verified techniques. So those techniques will work just as well against AI as well as they work against Hacker Man. Yeah, and just very briefly, for a more detailed discussion of how LLMs work, this Ars Technica article, a jargon-free explanation of how AI large language models work, is a really good one. And for more discussion in detail of the problems with AI predictions, Rodney Brooks was head of the MIT AI lab and computer science lab, one of the leading lights in autonomous robotics, and he writes very regularly about a lot of the problems with AI predictions from someone who is very much inside that industry. Okay, thank you very much. Any questions if we have any time?
Question two, yeah. Models being
Thank you so much, because I forgot to talk about it. It's a really nasty problem. It's a fundamental issue in the data sets. And anyone talking about existential, well, some people in AI are talking about, oh, well, we should worry more about the existential threat. We shouldn't. We should worry about the actual problems that are in it here and now. And those are those problems. Yep.
So, you talk about hacking AI. There was obviously that experiment they did with Wire where they, for autonomous systems vehicles, they took a 10 km/h speed limit and much like the duck one, they added a tiny triangle on one of the 10 and corresponding for the 100 km/h speed limit and went moving off down the road. What's your feeling on if that then resulted in a crash? AI system responsible, or is the person who put the triangle on the sign responsible for murder?
I would say the person, well, I'm not a lawyer. I think the lawyers, I would imagine that the person, if the point of the triangle was to mess up the speed limit and the speed limit messing up led to someone dying, then I think the person who put the triangle on there would probably be answering some questions from the police. Yeah, I guess, I think the law would try and work their way around it, but yeah. I think in cybersecurity, it's a much bigger issue. Like, I think one thing for that issue is that it's not like people aren't going around trying to like crash cars that often because of all the negative results for it. But cybersecurity, messing with other people is kind of what happens all the time. So, yep, Stephen.
I'm really glad that we kind of like totally.
Yeah.
I'm really very.
That's how I felt like about halfway through your talk.
At my level, and given that you are actually like probably next in the field, how do we get to the next AI wins it faster?
Tremendous question. Well, I guess I'm a kind of a testing and measurement wonk, so I think more focus and more publicity for actually testing these systems and showing the problems. Apart from that, I think the more, I guess particularly in our field, the more people start to actively break them, that might, and the more visible that gets, that might accelerate it a bit. Keep reaching for that dream. Perfect. Thank you very much.